In section 7.3, we're going to cover polygons and perimeter. A polygon is a closed geometric figure whose sides are line segments and are classified according to the number of sides. These figures are called polygons. So for example, if you wanted to see some polygons that you may have already encountered before, things like triangles, squares, um, pentagons, for example, these are all examples of polygons. They're closed geometric figures, closed meaning that there's a definitive inside and outside of each region, and it's important that the sides are composed of straight line segments. If I come over to here, these types of objects would not be polygons. So this kind of like upside down ice cream cone looking thing, and kind of like this broken line graph. The reason why this would not be a polygon is because you have a side that's not a straight line, it's actually rounded. It is, however, closed, whereas this one, even though it's comprised of entirely straight line segments, it's not a polygon because it's not closed. There's no inside or outside. The figure is not like completed. We typically name our polygons a few different ways. The most basic classification is simply on the number of sides that the polygon has. Most of us should be familiar with a lot of these. We have a triangle is one that has 3 sides. Quadrilateral, quad meaning 4, is a 4-sided closed geometric figure. Pentagon has 5 sides. Hexagon, 6. Hepta is 7. Octagon is 8. A nonagon would be a 9-sided figure. And then a decagon would be 10 sides. These are the most common geometric figures, and you should know the names for each one of these. There are additional names as we kind of go higher in terms of number of sides, but these are the standard ones that we'll be using. The first thing we want to study is the angles in a polygon. Okay. For example, we already talked about earlier that if we add all of the angles in a triangle, that it adds up to 180 degrees. If I had a 4-sided polygon, let's take a look at this shape over here. If I had a 4-sided polygon, one of the things we could do is we could connect 2 vertices that would create 2 triangles. And if you think about what are all of the angles that would be in the quadrilateral, well, these are the angles of my quadrilateral. There's this one, this one, this one, and this one. And if I notice, that is kind of broken up via the angles in the triangle. If I take this, this, and this, that would give me all of the angles in this bottom triangle, which we know adds up to 180 degrees. And if I take all of the angles in the top quadrilateral, that would be this angle, and this angle. Notice that those two add up to 180 degrees, and in total, they would give us the interior angles of the quadrilateral, which is going to be 360 degrees. So the sum of the interior angles in a quadrilateral is going to be 360. Let's see if we can do this for a pentagon before showing the general formula. So let's suppose I have a pentagon. This is going to be our 5-sided geometric figure. And what I want to do is I want to break this into triangles. So I could, for example, start with this vertex. I can make a triangle here. And then I could take, and from this vertex, make a triangle there. And I have now split my 5-sided geometric figure. So the pentagon has 5 sides. And notice that it's broken apart into 1, 2, 3 triangles. If I add up the angles of all 3 of those triangles, well, we know each triangle adds up to 180, and if we have 3 of them, that should give us 540 degrees. So let's look for a pattern here. When we had a quadrilateral, we saw a moment ago we got 2 triangles for 180. which gave us 360 degrees in a triangle. When we had just our basic old triangle, which is what everything is based off of, that was just one triangle for 180, which gave us 180 degrees. And there's a pattern here. If I wanted to find the number of angles in, let's say, a hexagon, or a six-sided figure, notice that when you do this subdividing trick, the number of triangles you get is always 2 less than the number of sides. So for a hexagon, the measure of the interior angle should be 6 minus 2 times 180 degrees, which is going to be 4 times 180, which should be 720. And in general, it's one of our first formulas of the chapter. You have to know this will be on the formula sheet. But this formula here gives the measure of the interior angles of a polygon. If the polygon has n sides, you just take n minus 2 and multiply it by 180. In the next example, let's see if we can find the measure of the angles in a heptagon. If it's a heptagon, that means that it's going to have 7 sides. The formula is n minus 2 times 180 degrees. So this should be 7 minus 2 times 180, which is going to be 5 times 180, which should be 900 degrees. So the measure of the angles in a heptagon would be 900. Just as there are special names for certain types of triangles, if you recall, we had things like isosceles and right. We had obtuse and acute. There are also certain types of names for quadrilaterals, depending upon certain relationships of the angles and sides. The first special type of 4-sided polygon is what's called a trapezoid. A trapezoid has exactly two pairs of parallel sides. If I look at this trapezoid, this side and this side are parallel to each other, but the other two sides would not be. In a parallelogram, if we have 2 pairs of parallel sides, this side is parallel to this side, and also, let me see if I can highlight it, this side is parallel to that side. That creates a parallelogram. So in a trapezoid, you have 1 pair of parallel sides, and in a parallelogram, there's 2 pairs of parallel sides. If our parallelogram has all 4 angles that are right angles, meaning 90 degrees, then that creates a rectangle. If our parallelogram has the sides so that they all have exactly the same length, then that makes a rhombus. And if we have a rhombus where all of the angles are right angles, which is a special type of rectangle, then that gives us a square. So a square has all equal sides and all equal angles. So some of these relationships are shared. For example, if you are a parallelogram or a trapezoid or any of these other ones, you are certainly a quadrilateral because they all have 4 sides. If you only have 1 pair of parallel sides, that makes you a trapezoid. But if you have 2 pairs of parallel sides, that makes you a parallelogram. If, in addition, if all of the sides are equal in your parallelogram, if all of the sides are equal, then that gives you a rhombus. And if all of the angles are equal, meaning 90 degrees, then that gives you a rectangle. And if you have it such that both all of the sides are equal and all of the angles are equal, then that makes it a square. So kind of from most specific all the way up the chain to least specific. So for example, a square is also a rhombus, is a parallelogram, is a quadrilateral. Okay. However, a rhombus is not necessarily a rectangle because in a rhombus, all of the sides have to be equal, but in a rectangle, we know that that's not necessarily the case. Also, too, in a rectangle, the angles are all 90, whereas in a rhombus, they would all not be 90 degrees. We now come to the notion of a regular polygon. In a regular polygon, all of the sides have the same length, and all of the angles have equal measure. The most common example of regular polygons are the squares and equilateral triangles. For example, if we have an equilateral triangle, we know that all of the sides are going to be the same and all of the angles are going to be the same as well. What that would mean for your triangle is if the sum of the angles adds up to 180 and we divide it evenly into 3 pieces, then that means that each angle would be 60 degrees. We already know that if we have a square, all of the sides are equal, and we know that each of those angles is 90 degrees. Again, in any quadrilateral, we saw that the sum of the interior angles is 360. We divide that into 4 equal pieces, and that shows us that each angle in a square is going to be 90. So let's see if we can find the measure of each angle of a regular hexagon. The first thing we would need to do is find out, well, what is the total angles for the entire object? And that comes from our formula n minus 2 times 180. We did this earlier, and we saw that the total angles in a hexagon is 720. Hexagon meaning 6 sides. If all of the angles are equal, then that 720 is divided equally up amongst the 6 sides, and that would give us that the measure of each angle would be 120 degrees. So if I try to draw my best regular hexagon here, each of these angles, each of these angles would have a measure of 120. If we wanted to kind of extrapolate what we just saw here, if you have, for example, if we have a regular polygon, the measure of each interior angle would be the following. It's the total angle, which is n minus 2 times 180, and then you would just divide this by n because it's split into n equal pieces. So if you wanted a general formula, this is what it would look like. N minus 2 times 180 divided by n. The next concept we're going to come to in geometry is that of perimeter. And just simply put, the perimeter of an object is the distance around the outside. If we're working with polygons, then it's just a matter of adding up the length of all of its sides. And for some of these objects, we can create certain perimeter formulas. But again, the concept is pretty basic. You don't even necessarily need a formula for these, although it is helpful. But just know that when we're talking about perimeter, you're just adding up all of the sides. In a triangle, if we have sides A, B, and C, the perimeter is just A plus B plus C. If we had a square, notice that all of the sides would have the same length. If I call that common length S, then it's just S plus S plus S plus S, which we can write more compactly as 4 times S. So the perimeter for a square is 4 times the side length. And then if we look at, let's say, a rectangle, for instance, we know that there's a certain length and a certain width to that rectangle. Even though it's not listed, this is also equal to the length. This is also equal to the width. So if we were to go ahead and add up all of the sides of the rectangle, you'd have 2 W values added together and 2 L values added together, which we can write in shorthand as 2L plus 2W. So the perimeter of a rectangle is 2 times the length plus 2 times the width. Let's take a look at an example. It says the Hauser family finds their dream home perfect in every way except one. The backyard is not fenced in and their dog needs room to roam. The rectangular portion they decide to enclose is 95 feet by 70 feet long. How much fence will they need to enclose on all 4 sides? So they want to enclose all 4 sides of this backyard. We know that it's 95 feet by 70 feet. And if we're going to install fencing, that's going to go around the outside of the border. So we're talking about the perimeter of this. It's a rectangle. So we know the formula for the perimeter of a rectangle. It's 2L plus 2w. That's going to be 2 times 95 plus 2 times 70. 2 times 95 is going to be 190. 2 times 70 is 140. And if we add those together, we should get 330. And it's a linear distance, so that's going to be in feet. So the perimeter is equal to 330 feet. Let's take a look at the next example. They say that the length of each wall of the pentagon is 921 feet. So I'm just going to try and do a rough sketch here. So each of these is 921 feet. Again, penta means 5 sides. Suppose that a sentry must walk the outside wall 6 times during his 4-hour shift. How many miles does he walk in one shift? So this is one of our word problems. So we kind of need to read it through, see if we can understand exactly what's being asked of us. Here we're asked to find the distance this person walks in miles. To start, notice that they say that they're going to walk around the outside 6 times. So that should be 6 times the perimeter of this figure. Well, let's find the perimeter of this pentagon. Each side is 921 feet, and there's 5 sides altogether. So in order to walk around the outside once, it would be 921 times 5, which is going to be 4,605 feet. That represents the distance of going around this figure exactly 1 time. Since this person is going to do it 6 times, we need 6 times the perimeter for the total distance. That's going to be 6 times 4,605. And that would give us a distance of 27,630 feet. That's great. We now know the total distance the person walks, but they want to know what does it look like in miles, not feet. So we have one of our US to US conversions. And I'm not requiring you to memorize this. There'll be a sheet with this if you need it. But remember that 1 mile is 5,280 feet. So you set up your bridge. The feet cancel. We end up taking the 27,000, dividing it by our 5,280, and we get to the nearest tenth. Let's call it 5.2 miles. So that sentry, if they walk around that outside 6 times, will have covered a distance of 5.2 miles.